Ram Shankar, a Berkman Klein Center affiliate, and people know you as working at the intersection of machine learning and security. Welcome to the Data Exchange Podcast.
Hey, thanks for having me, Ben. Really appreciate in this very interesting time to talk about something that I'm passionate about. Is a really big mind reprieve. I also work at the Azure Trustworthy Machine Learning Group at Microsoft. I'm not here to like specifically speak or represent Microsoft views, but I'm really excited, like I said at the beginning, to talk about something in these very interesting times that I'm passionate about. So thanks for making this space.
So in this conversation, there's two areas that we're going to talk about: security and
Hmm.
machine learning. So I'm going to
Hmm.
start with how security is impacting machine learning. So and then we'll go the reverse: how machine learning is impacting security in the second half. So first, why should machine learning people care about security, Ram?
Oh, that's a great question.
Isn't isn't that the job of a security team?
Oh, I love that. Oh, that's a great prompt.
Uh,
One of the things that I think as we as ML researchers are really good at is making big impacts, right? If you think of like any thing that's having like economic or like societal transformations from finance, healthcare, cybersecurity, even, or defense or infrastructure, machine learning is like at the core piece of what's setting this transformation. And I don't have to this is like preaching to the choir. One of the things that we as practitioners need to be mindful of is that in the eagerness to kind of like capitalize on this transformation, we don't necessarily always think about the security of the system, which is like, and I'll talk a little bit towards the end about like how academic researchers are like heads and shoulders about. But as ML practitioners, like we care about performance, or like we optimize for like metrics that we care about, which might be like accuracy or click-through rates or NDCG, or like, whatever metric that you're kind of caring about. The problem is it's really hard to secure a system if security is like a bolt-on and not if it's built in. And the internet is a great example of like how if you don't think about security from the get-go, like we are where we are, right? If you think about internet started off as this very similar parallel to machine learning. It started off as a technology for what Jonathan Zittrain from Berkman calls a generational content. Like this is like empowering people. And then slowly you started seeing like a spate of attacks. Like, everybody remembers like, the worms of the prehistoric ages in the internet, which caused like devastating havocs. And then there was like almost a come to Jesus moment in the computer security field to think about, okay, we need to secure the internet and we need to be very mindful about it. And we're not there yet. And the internet is like, what, 20 plus year old technology that's like affecting the lives of people, and we haven't gotten that right. So if you're a machine learning engineer and you're already creating this transformational impact, if you're not thinking about security from the get-go, it's just net societal loss.
so the reason I ask you the question in that facetious way is the following, right? So because many times when people read about machine learning being attacked or being
Mm-hmm.
insecure, they
Mm-hmm.
may say, "Well, that's the kind of application that doesn't apply to me. That's computer vision, or
Oh.
that's some obscure, that's some theoretical academic paper where they fiddle with some pixels, right? So
Mm-hmm.
I'm
Mm-hmm.
building a recommendation system or a forecasting
Mm.
tool. So uh, does this really affect me?"
Oh, I love that. That's a great framing. So you're definitely right that, as I alluded in the beginning, that academic researchers are like head and shoulders about this field. In fact, this field goes back to 2004. There's a wonderful like paper by Battista Biggio called Wild Patterns that really traces back like the lineage of adversarial machine learning, which by the way did not start in 2014 by the seminal Skegedy paper. It was like it goes back all the way like 2004. So we constantly see like even like academic researchers trying to topple commercial ML systems. So, this has happened many times. There's a paper this year at NDSS called Cloud Leak, which is able to replicate ML models with 99% accuracy with lesser than like 400 queries across like all machine learning services, Microsoft's cognitive services, Google API, IBM, Clarify, a whole host of like product.
And why is this bad?
Oh, and why is this what?
Why is this bad?
Oh, it's a great question. So why is this bad? So the fact that think of I always think of the Caddy Metz article in the New York Times. Like, it says that, companies are paying like ML engineers NFL style salaries, to kind of get that competitive edge. Now, think about it, right? If you're a
Right.
business decision maker and you're investing NFL style salaries, which I hope, everybody gets, to get the competitive edge. And here comes like an adversary who can kind of replicate your ML model with less than 300 queries with 99% accuracy. You're kind of like all of a sudden losing your competitive edge. You're kind of almost like developing and giving it away for free for somebody else to use.
Let me
So, yeah.
let me drill down. So when you say replicate, so let's say for to make this concrete, I have some kind of recommender system.
Mm-hmm, mm-hmm.
So is it really true that you can replicate it with 300 to 400 queries? I mean, in the sense that you don't have any of my data.
Mm-hmm. Mm-hmm.
Um, so if that, so how practically is how practical are these threats? I guess is the
That's a great point. So first of all, I've not encountered a paper on recommender engines. I don't want to kind of like
yeah
mislead our audience
yeah.
about recommender engines. But let's kind of like take the canonical example that I have in my mind about OpenAI's GPT-2, right? OpenAI's GPT-2, not GPT-3, by the way, GPT-2. Last year, when they released their seminal paper on Feb 2019, they said, you know what? This is too dangerous to release. We're not going to release our 1.5 billion parameter model immediately. We are going to adopt a staged release process, and we are going to release it like we're going to take our time, make sure that it doesn't like havoc society, and then we'll slowly release it. Um, Now, when you tell the internet, and I can tell you as a security engineer that you can do something, it's like the gauntlet has been thrown. So Vanya Cohen and uh, uh, Aaron, I forget his last name, but he goes in this a researcher handle, Skyline on Twitter, kind of like before OpenAI kind of released their ML model, they were able to like replicate GPT-2. They called it Open GPT-2, and they put that out on the internet for people to use. Now, I do want to kind of like pause here for like a pedantic clarification. First of all, there's a big difference between model extraction and model replication. Model extraction is when you can almost steal the model with very similar accuracy as that of the original model. In model replication, you're kind of like just approximating the model. So it doesn't have the same metrics as the original model. So the GPT-2 is a model replication attack. It's not a model extraction attack. Just want to make that clear. So yeah, now coming back to our like main story again. So here, Vanya Cohen and they all kind of replicated GPT-2. They put that out on the internet. And my favorite tagline in my mind is, even to this day, Vanya Cohen's like Twitter handle is a GPT-2 model of lesser or equal value, which I think is a good like nudge nudge. So how do they do this? Like at that point, they did not have the original data set that was trained on. So how did they kind of get to do this? Turns out that you can do a lot of reconnaissance, because of like the PR blogs, like the archive papers that are being published. So first of all, they did that. They were able to get even read the original paper, get like an idea of what GPT-2's like loss function was. that's something that they were able to extract. The second thing they were able to is like because GPT-2 was trained on publicly available data sets, they created like similar data sets. So the data set problem is also kind of like changed. So what they did, the third thing, which I think is really smart, is that they took Grover, which is like another language model released by Allen Institute, and they used the objective function that was from OpenAI's GPT-2 and retrained it on the GPT-2's datasets, which in turn modified the weights of the original Grover model, which now started, having like similar guarantees as that as OpenAI. Now, it's not the same metrics. I want to be very clear. It's not the same Open GPT-2, original GPT-2 model in terms of metrics, but the fact that you can do this, you as a business decision maker are now left with this very interesting conundrum. Because on the one hand, machine learning has been built on this norm and this protocol of like being open and transparent. There's this wonderful paper by Jan LeCun, Alex Mola, like way back in, I want to say 2007, that shows about like why like machine learning should be open. And now if you go back and look at most of the authors and papers are like engineering leaders and like all these like organizations trying to like advocate for openness. On the other hand, you want to think about it like when you're training on publicly available data sets, or when you're like having this compute that's now democratized, how much are you kind of like giving away? Um, now I
Well,
don't want.
well, here's a concrete example, and I'd like to get your take.
Mhm.
Google search engine ranking.
Absolutely, yes.
So they're not gonna tell you exactly how they do that, because otherwise
Mhm.
you game it, right? But
Yeah.
then they have to explain it a little bit, because in many ways, right now there uh, all sorts of regulators are calling them out, right? So they have to provide some high level description of how it works. But then, how do you do that without giving away the actual mechanics of the system, right?
Oh, Ben, you are hitting it on the nail. First of all, like I definitely want to make my position unequivocal. We're not advocating security by obscurity. It's a terrible, terrible like strategy. You want to be open as much as you can. We are advocating for transparency. Um, I also want to. I'm just trying to highlight the tension that you kind of mentioned, right? Like explainability and security. Hima Lakaraju at Harvard wrote this like again almost path-breaking paper, kind of like really like diving into the details of how the more you make there's this inherent trade-off between explainability and security, and she goes through these attacks wherein like how explainable learners almost tend to be more vulnerable to like attacks on them. And a very easy like the rule of thumb that a very big picture idea that I have is like think of linear learners, right? They're extremely like explainable, like for obvious reasons, but they're also extremely vulnerable to adversarial examples. So you can't have your cake and eat it too. In fact, the European Union kind of like High Commission on Trustworthiness of AI released a comprehensive checklist of like things that to make your ML system like essentially trustworthy. And I always, and when you read the section on explainability and when you read the section on security, you kind of almost want to think, are these at odds? Are these like at odds with each other? Which is what you're kind of like referring to as well, Ben. So absolutely agree with you.
So you initially kind of hinted that, so one reason why ML people should care about security
Mm-hmm.
is to some extent IP, right? So to protect intellectual property in some sense.
Mm-hmm.
Um, but obviously, there's also the notion RAM of privacy, right? Because
Absolutely.
you don't want to leak, uh, I guess, personally identifiable information, or even other sorts of information. But then also, so there's other
Mm-hmm.
issues as well that that are related to security, and those are safety and reliability, right?
Oh, absolutely. We'll first double click on privacy. There's this like attack called model inversion attacks, which essentially tell you, which help you kind of like um, recreate the features of your data set. Just again, just by querying, by strategically querying and observing the response. You do not, assumes like a black box style ML model. And think about it for a second. Um, um, if you can like, there might be some features that are essentially private, which you might not want to share about, which is like, again, like a big privacy sort of violation. But the more direct one is like membership inference, when you can essentially, again, by strategically querying your ML model and observing the response, you as an adversary can try to ascertain if a training point, if a data point was part of the training data set or not. And that
Oh,
again, sorry, go ahead.
does differential privacy guard against
Yeah, that's a great point. There's great work done by Kamalika Chowdhury at UCSD trying to ascertain like what kind of differential privacy notions can membership inference attack also kind of thwart. The example that I carry in my mind in the seminal like membership inference paper was um, they were it was I believe it was University of Texas Austin's like medical data set, if I remember like that example correctly. And just by knowing like, like very banal information like age, sex, like ID, they were able to ascertain like whether if a person was part of a procedure or not. Again, which Ben, you're classically alluded to a big like violation of PII. And think of all like now with the GDPR style fines that may be kind of like incurred by your organization. You definitely do want to think about that. Now, when it comes to safety and reliability, I will first confess that I am not an expert on this area. It's something that I've stood by the bylines and watched people like Samir Singh and a whole host of other people kind of like work on it. I can tell you that the classic paper that comes to my mind is the Concrete Problems in AI Safety by Chris Ola and Dario and a host of other people. And it's quite quite a hard problem to solve because in my area, when I think about security and machine learning, I always have in my mind intentional failure modes. So, this is when an adversary is actively trying to assault the confidentiality, the integrity, the availability of the machine learning systems. What in the safety and reliability group, that area, that pocket of research focuses on is like unintentional failure modes. So again, the classic example that your audience will know is like reward hacking or wireheading, right? Trying a designer may have when the ML system performs like an action that is inconsistent with the benevolent designer's like intent. So an example that that they kind of use is think of like a like a vacuum cleaner that's trained on reinforcement learning that's like trying to do some exploration of the system, exploration of the space, and then try to like exploit the things that it gets good rewards for. And they talk about this hypothetical example of like as it's exploring, like what if this vacuum cleaner kind of inserts a wet mop into an electrical outlet, or if it's just rewarded for like positive actions of cleaning, what if the vacuum cleaner kind of like breaks a vase and then cleans it up because now it's like cleaning and therefore it gets like better things. There's an entire list of like reward hacking examples by the researcher at DeepMind. Um, her name is Victoria, and I'm
I
not
think
saying.
I think I know who you're referring to. I just can't think of her name. Yeah.
Yeah, I'm not. I don't want to say her last name incorrectly, but it starts with a K. And she's got an entire list of like unintentional. I mean, like reward hacking style, but you know. very fascinating, like how like this agent stops playing the Tetris game because it anticipates that every move is going to be a loss. Therefore, it just pauses the game indefinitely. So there's all these like unintentional failure modes, and I use the word unintentional in the safety and reliability context because like it was not what the designer intended to, but kind of like what the machine learning system essentially kind of performs. So then there's this whole host of other things with the safety and reliability, like research cohorts are doing, which could be like attributed to data drift. It could be attributed to, um, um, like mismatch and kind of like design. And I can tell you, Ben, I am just, as a security person, who I feel even more overwhelmed that not only do we have to care about the security of the system, but also the net safety and net reliability. It's a field that I only look up to in awe and awesomeness.
So by the way, we're at the point, as you noted earlier, as we opened the podcast, that machine learning is growing, right? So more
Mm-hmm,
and more
mm-hmm,
companies are interested in machine learning, and then the community itself and the general public is aware of all these issues that we've been talking about,
mm-hmm.
which some people are calling responsible AI, responsible machine
Yep.
learning, right? So that's
Mm-hmm, mm-hmm,
security, privacy, safety, reliability,
mm-hmm.
transparency, all of these things. And then because the machine learning teams are under pressure to deploy to production, they're
Mm,
now starting to think about things like ML ops, right? So how do we have
mm-hmm,
formal processes for productionizing systems? So they're looking into areas like CI/CD in software
absolutely.
engineering to figure out if there's any inspiration that we can draw there, and then they're building tools that will allow them to do these
Mm-hmm,
end to end.
mm-hmm,
But then you have the responsible AI, right? So
mm-hmm.
then I mean, to what and I'm actually, so I'm kind of talking to both communities, and I'm not quite sure to what extent the MLOps tools
Mm.
are really integrating some of these responsible AI checks. Because
Oh,
right now the uh, the pressure is to move fast and deploy, right?
absolutely. Oh, Ben, that's such an astute observation, and it's very much tracking to what we see in the industry, and we see kind of like even the academic research. I will tell you there are some notable highlights, like Nicholas Papernot from University of Toronto, really was one of the very earlier like adversarial ML researchers to come and say, "Hey, we need to think about like monitoring and auditing of machine learning systems. Like this is important. Like you should like really think about engineering aspects." And then there's obviously like Nicholas Carlini, who made a very cool observation in his keynote at a Camless conference. He said the machine learning. Uh, let me rephrase. He said that the machine learning uh, era is like how it's crypto pre-Shannon. So we are now like deploying ML systems without thinking about like security of like the actual system itself.
Yeah, because they're still the ML teams are still at the point where, okay, so we need tools for experiment tracking and management, reproducibility. So they're coping with that data lineage, right? So then to what extent? Because I think it's fair to say, Ram, that responsible AI will have to be a multidisciplinary effort, right? So you've got
Oh,
security, compliance, UX, even, right? So
oh, absolutely.
besides ML and data science, right?
Oh my gosh, you are so right. Like the even if you have to double click on your ML ops
Right,
example, right?
right, right,
We don't have static analysis tools for ML systems.
right.
There is no like concept of dynamic analysis tool for like machine learning systems. Think about something as basic as like a trust score, right? There are some startups that I'm seeing right now.
Or notions from software engineering like unit tests, integration testing. I think your colleague at Microsoft Research, Marco Ribeiro,
oh yeah.
he has a new paper called Checklist where they're doing black box testing for NLP, right?
Oh, I didn't know this. Oh, Marco Rubero is like such a prolific author.
Yeah,
It's no
yeah.
wonder I miss it.
So what they do is they do behavioral testing for
Ah,
for NLP, but it's early days.
totally.
But you can imagine behavioral testing for ML in general.
Absolutely.
The takeaway from talking with someone like Marco is it's early days. So 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 in other words, there's a ton of things deployed out there that never went through all of these steps.
Yeah, it's very interesting, right? Like, if you have to take the unit test, the way I think about this is like, there's definitely some, at least at Microsoft, there's like, the software development lifecycle. You would have to do threat modeling. You would have to do like, like good coding practice, like unit tests, like integration tests, before deploying it to like the ML model. But here's the deal: there's a different. You were so right in saying that it's such an early stage because we haven't done like an end-to-end testing of the ML algorithm, the algorithmic piece itself.
Which, by the way, now there's two pieces: data and the model, right?
Exactly. Oh, totally. Yeah, you're totally right. So that part has not happened.
And it's inherently probabilistic, right?
Oh, that's gonna
Right.
be like
So
harder.
that's going to be harder all around, right?
Yeah, I remember listening to this talk from this researcher from DeepMind. I'm sorry, I will like get his name. I'll look it up as well. Called spec consistent AI. Like, how do you develop like spec consistent like machine learning system? We're nowhere there yet, Ben.
Right. Right.
It's a tantalizing
So
area.
obviously, Ram. So not that we've talked about this way, but kind of in the back of my mind as we're talking about ML systems that
Mm-hmm.
are either deployed in the cloud or in massive servers. But
Mm-hmm.
as the listeners know, ML is in embedded devices, is in mobile phones.
Yeah.
So let's assume, for the sake of argument, that all the ML models in the cloud are unit tested or all so on and so
Mm.
forth. What about the edge, man?
Oh, Ben, you're so good at honing in on things that make me uncomfortable.
Yeah,
Uh, it it's insane, Ben. Like,
yeah,
if you listen, after listening to Pete Warden's talks
yeah,
on like, like how you can squeeze like ML models into like low power devices,
yeah.
what is their
Microcontrollers, yeah.
microcontrollers like? What is their patching policy? Like, how do you go patch like? I
Zero
did,
day.
yeah, this is getting into the realm of like just forensics, right? The thing
Yeah,
that I like to think about is forensics. If you go today to the NIST website for forensics, for traditional like software systems, it's broken down by operating system, edge, like like insane amount. You can like pick and choose and things that you want to do. Like, you wanted to take a memory dump. Oh yeah, there are like bazillion tools. Think about the forensics of a compromised machine learning system. What does that mean in the context of like machine learning as a service paradigm? Like ML systems running on the edge. And ML systems that are being hosted on servers. It's such a big
so a
area
friend of
of.
mine, Yishai Carmiel, who I'll have on the podcast soon as well,
Ooh.
they are putting together a knowledge base for AI security, so that
Oh,
people can organize, and it'll be open source. So at least people can go in there and make contributions, update it, but they'll at least have some initial version of this knowledge base. And Ram,
oh, Ben.
one of the things I want to ask you is um, ML. So I don't know. So feel free to push back, but I've also spent a little time in security. Obviously, not as much as you, but does it make sense to have something equivalent to penetration testing for ML?
Oh, absolutely. There are people on it, Ben. Will Pierce, who kind of like reported the first CVE at a commercial ML system, is now heading at Microsoft. I'm so glad that he's part. I get to work with him every day. Kind of like his whole job is to work is to like go and red team machine learning systems. But we're not the only ones doing it. Christian Cantor from Facebook is the head of the AI red team. Again, doing fantastic work on like systematically testing like machine learning systems for faults. And the more we talk to like other like organizations, even at Nvidia, there's this like big push on like red teaming like ML systems. Um, it's a journey that people have already started on, and very very interesting and validating some of the work that's already happening, but also thinking about like things that has not been necessarily thought about.
But
Failures are everywhere now.
in software and web applications, they have this whole RAM ecosystem of open source tools like Nmap. You know,
Hmm.
uh,
Absolutely.
so do we need this ecosystem of tools for testing ML models? They don't exist, right?
Yeah, that's a great point. If you're asking about things that it can take right now and run it against a production system, not necessarily. But the adversarial ML research community has put out a host of tools. There's Clever Hands, there is IBM Robustness Toolkit, which is now part of the Linux Foundation, which they have generously donated to. There's I forget like oh, oh gosh, oh man, I know Clever Hands. I know I use IBM Robustness Toolkit. There's one called like Metasploit for machine learning.
Oh, there's a
Uh,
Metasploit for ML?
that's what's the tagline for
Okay, yeah, yeah.
like this open source project. The thing is, Ben, there's all these things that are mushrooming out there. Unfortunately, I don't know if any of them, in our experience, is ready to just like take and like attack your ML system in production.
So do you know if there are enough AI and ML research groups, right? So like Google,
Yep.
DeepMind, Facebook,
Mhm.
OpenAI, and they release tools, right? A bunch of these groups have released tools for
Mhm.
reinforcement learning and things
Yep.
like this. But have any of these groups released tools around this kind of thing?
Um, Not that I'm aware of. I know that Google kind of has a tool called What If. But it's more on the level of like fairness, but not necessarily one from security standpoint. The only one that I can think of that is IBM Adversarial Robustness Toolkit, which I said that they have generously donated to the Linux Foundation now.
So the way machine learning research community, I guess, grades itself is against
Yeah.
is benchmarks, right? So let's go lower,
Yes.
lower, lower in the benchmarks.
Totally.
Um, but there's no so what I guess some areas of responsible AI, it's a
Mhm.
bit hard, right? So because basically, as I understand it, maybe there's not even a consensus on explainability, right? So what does that mean?
Totally.
So how does the community generally grade itself?
Oh, oh man,
Yeah, yeah.
that's a great question. I'll tell you that, again, your listeners might know, in 2018, Anisha Talier published a paper at ICLR that showed how seven of the nine papers published in that very conference was, with respect to defenses, were broken. So, long story short, if again, I just want to double click in if you look at like the whole like attacks on ML systems, if you just think of like the adversarial examples, which is what like a bulk of the papers are coming in
Across the board, right? So not just
across the
not just
board.
vision, there's text as well, right? So
Yeah, yeah, there's text as well. So if I'm just like thinking of like adversarial examples as like one bifurcation, there is like, some sort of like robustness checks that Alexander Madry kind of like his group has like a robustness benchmark that you can try to go benchmark against. Uh,
MIT, yeah,
yeah,
yeah, yeah.
and then when it comes to data sets challenges, Again, this is not necessarily adverse examples, but common corruption. So that's also another way to attack like ML systems. So if you take like an image and then you say crop and rotate, turns out that ML models also misrecognize it.
So should it be should so how in your mind, if you were the emperor of machine learning,
Oh boy,
how,
terrible at
how,
it.
how should it work? Should it be like, okay, let's compete on this data set for computer vision, let's say ImageNet, right? And then what? And then
Mm,
the top five. Okay, so we you guys have to also pass this other. No, because it's a
yeah,
kind of orthogonal, right? So it's almost like let's build the best model. We'll worry about
yeah,
securing it later.
yeah. I'm sorry, like I'm like keeping a big aside because I really want to. I have so many thoughts in this. I'm trying to like marshal this in a coherent fashion. I think like a bigger inspiration for me is DARPA's backdooring ML challenge, which is
Okay.
called Troch.ai, wherein like you get to backdoor like an ML system and then they verify. It's almost like a Kaggle style competition wherein like they release like some sort of like data points for you to kind of play around with, but then on our holdout system they kind of verify it. I have a lot of competing thoughts around it. It's great when DARPA does it, right? Like, it's trusted third party. It's almost like an escrow company. You can kind of like verify and put it out. But that also creates a single chokehold, like a choke point, right? Like for a big testing bed. So, if I wear my researcher hat on, I would love to get kudos for like, soda results. But if I wear like my engineer hat on, it means that every single time I have to like prove to somebody that it's passed through like their verification process. And it's kind of like not realistic to expect that every single like person who wants to get the best like result would have to go through this verification test bed, which is going to create a single point of like failure. So lo and behold, Ben, if I'm the emperor of like machine learning, I would just get a ton of brilliant people to look into this problem because I necessarily don't have the answer for it.
Yeah, because on the one hand, obviously, so the ML communities, uh, so they compete around benchmarks, right? So
Yes,
accuracy is the metric. But
totally.
as we pointed out in the real world now, people think that it's more than accuracy. It should be a responsible algorithm, right? So
Yes.
but then uh, it, the way it works, then it seems to me is that people, okay, so let's squeeze as much as we can as accuracy, and then we worry about these other areas later, right?
Oh boy, that's a red herring, right? First of all, turns out that when it at least comes to certifying robustness of like an ML system, um, Percy Liang's group from Stanford kind of like showed great results, showing like how there's inherent trade-off between like accuracy and robustness. And the competing hypothesis here is that yeah, it makes sense that that as like robustness goes up, like accuracy kind of comes down because robustness requires like higher like sample complexity. So if you're optimizing really really hard for like accuracy, at least in the certifying like robustness domain, you're not going to get like highly robust score as at least they define it. uh, so yeah, like in all things, Ben, like there's going to be trade-offs. There's going to be there's a trade-off that we know that exists between like robustness and explainability, and there's a very similar trade-off between like robustness and accuracy. Um, so yeah, I've all I can tell you is like I definitely do sometimes believe that we're caught between like between two hard problems.
So as I pointed out, right? So there's also the community and the movement around
Mm-hmm.
MLOps, right? So
Yep.
end to end, let's have tools and processes that will allow us to build the model end to end and update
Yeah.
it regularly. But as we pointed out, there's a lot of things that can go wrong in
Yeah.
each of these steps, and there's a lot of notions of wrong, right? So responsible AI has many components. So that our listeners don't get overwhelmed, Ram, what are some basic things they can do around securing ML?
It's a great question. Um, First of all, we don't want them to do anything different. Like as a starting step, right? If you're pushing out like any code into production, you perhaps have threat modeling that you almost always do. So as part of your bigger threat modeling process, ask questions like, what if like an attacker can taint the training data? Or what if the attacker can taint my inference data? And walk through like what are the different possibilities and have a plan. Like that is just step zero. Just have a plan for response, have a plan for remediation, and fold it into your existing process. Now, I completely understand as an engineer, you're already overwhelmed with getting things off the door. So instead of like adding to their cognitive load, just try to make like small changes. Have a response plan, have a remediation plan, do basic threat modeling. That's like, step zero almost. And this is something that you can kind of like, and we've put out like threat modeling guidance
But
on.
the notion of threat modeling is foreign to most ML people.
Yeah, so I was just about to, that's a
So
good
so
point.
this would mean they would have to have security people on their team, right?
Yeah, and which if you're like a startup with like 10 people, you're not most likely not going to have a security person in your and we want to make sure they're also pushing out code that is ML systems that are secure. So at docs@microsoft.com, if you search for like threat modeling of ML systems, it's pretty much the same guidance that that our organization kind of uses. We put it out in like the the thing for people to use. Now, if you are even before the threat modeling stage, I would kind of recommend you kind of get a high level overview of how ML systems can fail. So there's also like a taxonomy of like a very like basic, very tailored. This was done in collaboration with the Berkman Klein Center. Um, we kind of like took this whole broad like field of like attacking machine learning system, try to condense them into like broad buckets of like attacks on ML systems. So first step for first go to system go to is think about familiarize yourself with how ML systems can fail. The second thing is there is like threat modeling guidance that you can use right now before you push out an ML model out there into production. Try to do that as part of your existing good practice. It doesn't take too much time. It's perhaps like an extra 10 minutes of brainstorming, which will save you hours or if not days of angst when ultimately, if your ML system is compromised.
And are there ways for a machine learning person? Uh, so what are some resources for a machine learning person besides the ones that you
Totally.
named to get up to speed? Are there talks or classes or
Great question. There's a initiative by Hima Lakaraju and a whole bunch of like people who are working in the space. It's called Trustworthy Machine Learning, trustworthyml.org. I want to say, Ben, like I
Mhm.
will send you the website. They have compiled a fantastic set of resources across the trustworthy ML domain, looking at security, looking at explainability, linking to basic papers, but also linking to talks and also linking to classes and notes. Um, I would highly encourage if you're new to this field to start there and familiarize yourself. They also have a bi-weekly seminar series, which is actually public to people. So go familiarize yourself over there. The second thing is in every workshop, in every like major ML conference imaginable, and even every security conference imaginable. So I'm talking about like NeurIPS, ICLR, ICML, or if you're in the security domain, like IEEE S&P, like ACM CCS, there's almost always a workshop on like attacking and defending against like attacks on machine learning systems. So look at the proceedings. All these talks most of the times are like available on Slide Live or on YouTube. You can also go take a look at that if you're not like more if you're not a more class person. So to wrap up, like, there's this trustworthy ML like site that you can go look at the compiled resources. If you're more if you want more like review like papers, a great place to start is like any of these conferences, they would have workshops that you can go look into.
And so, if you were to look ahead 2 to 3 years, Ram, where would we be in this topic of secure ML? Would still be where we are at now?
Hopefully not. Um, See, there is like great momentum. I'm an impatient optimist by nature, so I see great amount of intellectuals working in this space. And also, if you look at just from a policy,
We need tools though, man, for developers. We need
totally, yeah, totally.
not just papers. I mean, I love research and papers, but the ones in the front lines need help, right?
Absolutely. I definitely do see. Here's what gives me hope. You know, if you look at, there's now like standard organizations, ISO, NIST, the BSI, that's kind of like coming up with standards for like, hey, you need to secure your ML systems. Here's a standard for trustworthiness. Once these standards become commonplace, Ben, everybody wants to get the certification. Everybody wants to get this gold star, which means this will like open up a cottage industry of like of tools that's going to give you that like certification that yes, you are like ISO secure. Your ML system is ISO trustworthy.
What's the timeline for this?
That is a big question. I'm gonna be like optimistic and say 3 to 4 years. I don't think it's going to be 2 to 3 years. I think it's going to be more like in the 4 year range.
Now, isn't there some pressure, indirect pressure or direct pressure from things like GDPR and CCPA?
Um, that's a good question. I don't know if there's like, again, I'm not like
Because
analyze
well,
GDPR.
but if you leak data,
Absolutely, I will tell you that every national AI strategy that has been released so far puts front and center security and safety of ML systems. Um, and there's been like even in the
including the one on your refrigerator and your washer dryer.
that's that again that you are double clicking on exactly the right things
Yeah,
now. Yes, there's like, first of all, there's obviously securing like the image recognition system that's being on a drone, right? But not all of us drive like military tanks to work every day. I
right,
mean,
right.
nobody drives to work any day anymore. But so there's different levels of security. There's different levels of like guarantees. And as it makes sense, we will slowly start seeing this percolating down to consumer products eventually. Like, yeah, the way to think about this is like that a lot of things got secure because there were like flagship attacks that compromised systems. We have not seen that in machine learning today. There's not been like a target style breach or like an even way before target or like like the Equifax breach that happened that kind of like triggered like a whole lot of regulation. So until we have that or we don't have that, a lot of this is going to be important, but it's not going to be like forced down, or there's not going to be a mandate that comes down to us.
I guess the one attack that probably people don't associate with ML, it
Mm-hmm.
would be basically social media disinformation, if right. So
Oh,
because basically, if you can manipulate how people consume information, if you know how to propagate information on these platforms,
oh,
which are governed by models. Right.
absolutely. This is again a great area. This is a great example of an area that is vital to our conversation, but at least me as an adversarial ML researcher, I've not looked into it. But that doesn't mean the field has not looked into it. In fact, Nicholas Papernot wrote a fantastic paper on with Dan Bonet and everybody else about how like attacks on ML systems can kind of lead to like misinformation as well. So there's a lot more like people working on misinformation, right? But from a security standpoint, how do you secure like an ML systems against misinformation, disinformation? Is something that I need to educate myself more.
Yeah, yeah, yeah. And with that, at the start of this conversation, I alluded to that we would talk about machine learning's impact and security, but
Yeah.
but we're out of time. But I will bring you back in 2021 to talk about
Absolutely.
that. Yeah, to talk about that. And with
Yeah.
that,
Thanks for making the space.
yeah, yeah. Thank you, Ram.
Absolutely, Ben.